Good morning children, I hope class 9 children are watching this video and I hope you must be keeping well. As we have just completed our linear equations in two variables and each and every exercise and almost all the questions from each and every exercise has been solved. I hope you must be having in your notebook, and from even R.S. Agrawal also many other exercises are there, examples are there, you must go through and you must practice. Today we are going to start chapter 3 and chapter 3 was left, coordinate geometry. So let's see. Today in this class we will see Cartesian system, some examples are there, and we will try to complete exercise 3.2 and exercise 3.3 from NCERT. Here we have coordinate geometry. These things, introduction, what has been given here, you see you have already studied how to locate a point on a number line. In simple number line you know how to locate numbers. Once again I am repeating, even I also have taught in the same class, here itself in this class. This is your number line, suppose this is origin, that is 0. Right side you are having positive numbers in this way, and left side we will have negative numbers in this way. So in this way, if you want to represent any number, can be represented on number line. Already you have learned. So these things I hope you will understand, just you go through properly. I don't think any difficulty you will be having, just you go through. And one exercise is also there here, exercise 3.1, just you go through, you will come to know. And here you see Rene Descartes, the great French mathematician of the 17th century, liked to lie in bed and think. One day when resting in bed, he solved the problem of describing the position of a point in a plane. In a plane, how a position of a point can be shown or can be represented, he found out. His method was a development of the older idea of latitude and longitude. In honor of Descartes, the system used for describing the position of a point in a plane is also known as the Cartesian system. So this we will see today. Here you see Cartesian system. You have studied the number line in the chapter on number system. On the number line, distances from a fixed point are marked in equal units, positively in one direction and negatively in the other direction. Suppose this is your number line, this is your origin. Right side we take positive numbers and left side we take negative numbers. The point from which the distances are marked is called origin, that you know. This is origin. We use the number line to represent the numbers by marking points on a line at equal distances. If 1 unit distance represents the number 1, then 3 unit distance represents the number 3, 0 being at the origin. The point in the positive direction at a distance r from the origin represents the number r. The point in the negative direction distance r from the origin represents the number minus r. Locations of different numbers on the number line are shown in 3.5 here you see. So if suppose this is already you have learned in number system, then also you see this is called origin. This side, if suppose 1 unit whatever measurement you have taken, suppose this is 5 centimeter or 1 centimeter or 1 inch, whatever unit you have taken. So if 1 has been marked, equal distance you will be having in each segment, you see. So suppose if 2 has been marked, if this 1 unit you have taken 5 centimeter, then 2 unit will be 10 centimeter, 3 unit will be 15 centimeter, and so on. In negative also the same thing will be there, this will be minus 10, minus 15 and all. So 1 unit, whatever measurement you have taken, the same equal distance you will be having positive side as well as negative side. If any number you are taking, suppose you have taken 5. So the distance between 0 and 5 will be same in between 0 and minus 5. So that is required to be kept in mind. Descartes invented the idea of tracing two such lines perpendicular to each other on a plane and locating points in the plane by referring them to these lines. The perpendicular lines may be in any distance such as in figure 3.6. But when we choose these two lines to locate a point in a plane in this chapter, one line will be horizontal and the other line will be vertical. So in this chapter when we will take this is horizontal line and this is vertical line. In vertical line also the same thing is there. One point has been taken origin. As in horizontal line, right side we take positive number, left side we take negative number. In vertical line, below 0 is taken negative numbers and above 0 we take positive numbers. That you need to remember. So in this chapter when we will take two lines, this will be perpendicular on each other and this horizontal line will be called x-axis. This can be denoted as x dash. Already in linear equations graph has been plotted, so you know. Here you see this vertical line is perpendicular on x-axis and this is called y-axis. Y and y dash. Y and y dash. And this intersecting point is denoted by O, where numbers start with 0 and this is called origin. So horizontal line and vertical line, two lines are taken and where they intersect, this point is called origin. Now here what you need to know, right side in horizontal line will be positive numbers in this way, left side in horizontal line will be negative number in this way, and in vertical line below 0 will be negative number and above 0 will be positive number in this way. So in this chapter we will see these two axes, this x-axis and y-axis, and where points will be located and how it will be located. Here you see. Combine both the lines in such a way that the two lines cross each other at their zeros. Means when you are combining these two lines, as what we had taken? We had taken horizontal line, suppose this is 0. We had taken this vertical line, suppose this is 0. So we have combined these both the lines where their origin are intersecting at the same point. So origin of x-axis is here and origin of y-axis is also here. This has been placed over here like this. So here you see x-axis and y-axis, right side positive axis, this is positive axis, this is negative axis. Here this side positive axis and this side negative axis. Now the horizontal line x dash x, here you see, is called the x-axis and the vertical line y dash is called the y-axis. The point where x dash x and y dash y cross is called the origin. Just now I told this is called origin and is denoted by O. Since the positive numbers lie on the directions OX and OY, OX and OY are called positive directions. OX and OY are called positive directions, and just opposite to it, y dash and x dash in this side, this will be called negative directions. Now you observe that the axis, plural of the word axis here you see, divide the plane into 4 parts. These 4 parts are called quadrants. That you need to remember. These 4 parts what you have, that is called quadrants. 1/4 quadrant means 1/4 part. And here you see quadrant 1, 2, 3 and 4. That has been numbered 1, 2, 3 and 4 anti-clockwise. Here you see anti-clockwise that has been numbered. So the plane consists of the axis and these quadrants. We call the plane the Cartesian plane, and the same plane, this plane is called Cartesian plane or the coordinate plane. This you need to remember. This plane is called Cartesian plane or coordinate plane or the XY plane. The axes are called the coordinate axis, and this axis, x-axis and y-axis, is called coordinate axis. Now let us see why this system is so basic to mathematics and how it is useful. Consider the following diagram where the axes are drawn on graph. Let us see the distances of the point PQ from the axis. From this we draw perpendiculars PM on x-axis and PN on y-axis. Similarly, we draw perpendicular QR and QS as shown. Here you see. This you try to understand. Here you have P, here you have Q. Now, from P, perpendicular has been drawn in both the axes, in x-axis and y-axis. So this is PM and PN. Perpendicular has been drawn from this point. In the same way from Q, perpendicular has been drawn in y-axis and x-axis. That is, here you have S and here you have R. Now, you find that the perpendicular distance of the point P from the y-axis measured along the positive direction of the x-axis is Pn is equal to OM, and that is equal to 4 units. The perpendicular distance of the point P from the y-axis, perpendicular distance is how much? Distance from N to P, and that is equal to O to M, and that is equal to 4. You can see this point P is how far from y-axis? 4 units. The perpendicular distance of the point P from the x-axis measured along the positive direction of y-axis is Pm is equal to OM. Here you see this. We have seen distance from the y-axis. Now you see distance from the x-axis. So how far it is? Pm or NO. The same length is there, so this is 3 units. So distance from the y-axis is 4 units. Distance from the x-axis is 3 units. The perpendicular distance of the point Q from the y-axis measured along the negative direction of the x-axis is QOR is equal to SQ, that is 6 units, and this is with x-axis, that is 2 units. In the same way you can see here Q is there. Q is how far from the y-axis? This is 6 units. And how far from x-axis? That is 2 units in negative direction. Now using these distances, how can we describe the point so that there is no confusion? We write the coordinates of a point using the following convention. This convention is very important that you remember. Here you see first we have the x coordinate of a point is its perpendicular distance from y-axis measured along the x-axis, positive along the positive direction of the x-axis and negative along the negative direction of the x-axis. For the point P it is plus 4 and Q it is minus 6, and the x coordinate is called the abscissa. This you need to remember. X coordinate is called abscissa. The y coordinate of a point is its perpendicular distance from x-axis measured along the y-axis, positive along the positive direction of the y-axis and negative along the negative direction of the y-axis. For the point P it is plus 3 and Q is equal to minus 2, and the y coordinate is called ordinate. So two things you have got, abscissa and ordinate. So what it is? Here you see. Here you see point P, where it is in this Cartesian plane. P is at, here you see, x will be what? 4. And y is what? 3. Where it is? This point P is at how far from y-axis? 4 units. That has been written on x-axis. 4. And in y-axis you see 3, means how far from x-axis? 3 units. So this is called abscissa and this is called ordinate. And in the same way here you see Q. X is what? Minus 6. And Y is what? Ordinate. Abscissa is minus 6. Ordinate is minus 2. So in this way we need to write down. So two things you have learned here. Abscissa and ordinate. This abscissa and ordinate, and you must remember what it is. In stating the coordinates of a point in the coordinate plane, the x coordinate comes first and the y coordinate later. We place the coordinates in brackets. Hence, the coordinates of P is equal to 4, 3 and coordinates of Q is equal to minus 6 and minus 2. Note that the coordinate describe a point in the plane uniquely. 3, 4 is not the same as 4, 3. Here you see, if you are writing as we had seen, abscissa and ordinate of P were 4 and 3. So 4 and 3 cannot be 3 and 4. Because when 3 and 4 you are saying, means x is equal to 3. This x is equal to 3 and y is equal to 4. This point you will be having. This point you will be having 3. So 4, 3 and 3, 4 cannot be. Here you have 4, 3. 3, 4 and 4, 3 cannot be equal. So this is abscissa and ordinate. This cannot be interchanged. Example 1 you see figure 3.11 and complete the following statements. Here you have. So these all the points have been given. Here you see. Here itself you try to learn what it is. So x and y or abscissa and ordinate of B will be what you see. Here you see x will be 4 and y will be 3. Here in this case you see x will be minus 3, means abscissa is minus 3 and y is what? 4. Here you see L. Here you have x minus 5 and y minus 4. Abscissa is minus 5, ordinate is minus 4. Here you have S. Here you see x is 3 and y is minus 4. So this solution has been given. So already that you understood, I hope. Just you go through. Example 2 you see, write the coordinates of the points marked on the axis in figure. Coordinates of points you have to write down. Here you see how we will write. Here you see B you have. What point you have? X is 0 and y is 3. X you have 0 and y is 3. So here you will be having 0 and 3. Here you see this is E. So E will be, here you have 2 by 3. Here you have this point is what? X is what? 2 by 3 and y is what? Y is, sorry, yes, y is 0. And here you see x is what? Minus 5. Y is what? 0. Here you have x is what? X is 0, y is minus 4. So in this way just to practice, I hope you will understand. And just you go through, explanation has been given. Here you have this also, this will be 0, 0. Then you have exercise 3.2. Write the answer of each of the following questions. What is the name of horizontal and vertical line drawn in to determine the position of any point in the Cartesian plane? So horizontal and vertical, two lines you have. Horizontal line is called x-axis, vertical line is called y-axis. What is the name of each part of the plane formed by these two lines? Already you have seen quadrant 1, 2, 3, 4. Write the name of the point where these two lines intersect, that is called origin. Two lines where it is getting intersected, that is called origin. Here you see figure 3.14 and write the following. The coordinates of B, coordinates of C, the point identified by the coordinate that already you have seen. So I hope you will be able to do this. The point identified by the coordinates 2 and -4, the abscissa of the point D. Abscissa of the point D. Here you see abscissa means x. So here you see this is 6. The ordinate of the point H. Here you see H, where you have here. So your coordinates are H. Your coordinates are what? -5 and -3. So you need to write only ordinate. This is -3. So I hope you have understood, you will be able to do. The coordinates of the point M. Here you see, where is M? Here you have coordinates of M. Here you see. Here X you have this is -3, and Y what you have 0. So these are the coordinates. Just you go through, I think you will be able to do just a plot in proper graph sheet, and then you find out coordinates, you will be able to solve. And these questions you need to solve, each and every question. So I hope you will complete that. And then we have plotting a point in the plane if its coordinates are given. If coordinates have been given, how will you plot? That already in linear equations you have learned. Example you see. Locate the point 5, 0, 0, 5, 2, 5, 5, 2, -3, 5, -3, -5, 5, -3 and 6, 1 in the Cartesian plane. This you see, I hope you will understand. Here you have, suppose we will plot x-axis and y-axis. Suppose this is O, this is x, x dash, x-axis, y and y dash, y-axis. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. -1, -2, -3, -4, -5, -6, -7. -1, -2, -3, -4, -5 and so on. Always when you are doing this exercise, this one or previous one, you need to have graph so that properly you will understand. Here you need to locate points 5, 0. 5, 0 means what? This is x and this is y. 5, x is 5. This is 5 and y is 0. Y is 0 means the same. So here you will have this point will be your 5 and 0. Then you have 0, 5 means x is 0, y is 5. So this will be 0, 5. Then you have 2, 5, x is 2 and y is 5, means this point. This point. You will be having 2, 5. Then you have 5, 2. 5, 2 means x you have 5 and y is 2. So this is 5. Then you have -3 and 5. X is -3 and y is 5. This is -3 and 5. Then you have -3 and -5. You have -3 and your -5. minus 3 and minus 5. Then you have 5 and minus 3. 5 and minus 3. Then you have 6 and 1. This is 6 and 1. This is 6 and 1. So in this way, point can be shown in Cartesian plane. So I hope you understood. So this has been shown. In the example above, you see that 5, 0, 0 and 0, 5 are not at the same position. Similarly, 5, 2 and 2, 5 are at different positions. Also, minus 3, 5 and 5, minus 3 are at different positions. By taking several such examples, you will find that if x is not equal to y, then the position of x, y in the Cartesian plane is different from the position of y, x. Means if x and y is not equal, if it is equal, then it may be, but it is not. Then, if it is not equal, then x, y coordinates cannot be equal to y, x. So, if we interchange the coordinates x and y, the position of y, x will differ from the position of x, y. This means that the order of x and y is important in x, y. Therefore, x, y is called an ordered pair. This is very important. This order should not be changed. Otherwise, different point will be in play. The ordered pair x, y is not equal to ordered pair of y, x. And if x is not equal to y. Also x, y is equal to y, x if x is equal to y. If x is equal to y, then this can be interchanged. Then you have plot the following ordered pairs x, y of numbers as points in the Cartesian plane. Use the scale 1 centimeter is equal to 1 unit on the axis. So these points have been given. You need to plot in Cartesian plane. Here you see. Suppose this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 and all. Here you will be having minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 1, minus 2, minus 3, minus 4. This is x-axis and this is y-axis. Y and y dash. This is y and y dash. Here you see minus 3 and 7. You have here you have minus 3 and 7. Here you have 5, 6 and 7. Somewhere here it will be minus 3 and 7. Then you have 0 minus 3.5. 0 you have 3.5 will be in between 3 and 4. So this will be 0 minus 3. Minus it is. So in negative side it will be. Here you have 0 and minus 3.5 will be in between 3 and 4. So here it will be 0 and minus 3.5. Then you have minus 1, 3. Minus 1 and 3. Here you will be having minus 1 and 3. Then you have 4, 4. This is x is 4, y is 4. 2 and minus 3. This is 2 and minus 3. This will be 2 and minus 3. I hope you understood. In this way, points can be shown. This has been done, you can see. So in this way, we have done up to there. Here you remark, you see, plotting of points in the Cartesian plane can be compared to some extent with drawing of graphs in different situations such as time distance graph, side perimeter graph, etc., which you have come across in earlier classes. In such situations, we may call the axis t-axis, d-axis, s-axis, p-axis, etc. in place of the x and y-axis. Then you have exercise 3.3. In which quadrant or on which axis do each of the points -2, 4, 3, -1, -1, 0, 1, 2 and -3, -5 lie? Verify your answer by locating them on the Cartesian plane. So it is just you need to plot in graph and you can see -2 and 4 in which quadrant it is coming. First, second, third or fourth. So you can, by seeing itself, you see -2 is where it means this will be in second quadrant. In second quadrant what we have, just you see. By seeing itself you will come to know. Suppose this is your x-axis and this is your y-axis. So here you have positive numbers. So positive in first quadrant. Here you will be having negative and positive. X-axis will be negative and y-axis will be positive in second quadrant. In third quadrant you will be having here negative and negative. It's negative and negative. This will be in third quadrant, and here you will be having positive and negative in fourth quadrant. So by seeing itself you will know. Here you see negative and positive. Negative and positive will be in second quadrant. Positive and negative you have fourth quadrant. Just you plot in graph and you will come to know. Otherwise, by seeing itself you will know. Next you see, plot the points x, y given in the following table in the plane, choosing suitable units of distance on the axis. So this you need to plot. I hope it is not required to be shown. Already I have explained many examples, so you will be able to do. So question number 1 and 2, only 2 questions are there. You solve in your proper graph sheet and remember and practice properly, so that you must not be having confusion. So in this way we have completed our chapter coordinate geometry. So few summary has been written here, you see. I don't think this is required to be explained because already I have explained all the things. Just you go through by yourself and you practice and again and again. I don't think any problem you will be having. So next day we will start this next topic. Until then, thank you.